So Euclid is a fantasy model. Bev is model afflicted.
Well, it's wrong.
Wait, Euclid is a fantasy. Have you read the book? It's called Euclid's Elements. That's really good. You should give it a look.
Well, it's
over.
wrong.
Yeah, well, probably one of the most perfect books ever wrote.
Well, it's
Mathematical
wrong.
as well.
Well, it's wrong.
What,
Isn't it?
Euclid's Elements are wrong?
No, it's wrong, isn't it?
I don't know. You say it's wrong. Like, you've
Well,
just
on
said
a
it
surface-
three or four times there. But how is
Yeah.
it wrong? You just say in that Euclid's Elements is wrong. Euclidean geometry
Yeah.
is wrong, Brenda.
Right.
This is getting old, Brent. I mean, come on, you've got to do better than that. How you're not going to sell many globes talking like that?
It's wrong.
Yep.
It's wrong because in the presence of gravity, space is non-Euclidean.
Hyperbolic geometry is not the same, right, as reality.
Okay, well, that's good.
However,
You did say it was in reality, though. So where would you find that?
It's a better description of reality than
Well,
Euclid.
it's wrong.
It's better.
What?
Do you have like the book on hyperbolic geometry with the author's name and all the definitions and axioms and all, or do you just
Should
add
be
it on as book 16 to Euclid? Like, what's going on?
Well, it's wrong.
so general relativity. So Euclid is a fantasy model. So Euclid is a fantasy. Bev is model afflicted.
Wait, Euclid is a fantasy. Have you read the book? It's called Euclid's Elements. That's really good. You should give it a look over.
Well, it's wrong.
So Euclid is a fantasy model.
That's child
Please
abuse.
don't be model afflicted like Brenda.
That's child abuse.
Bev,
That's child abuse.
you are model afflicted.
Euclid is fantasy,
That's child abuse.
but space-time geometry is real. Wow, Brenda, you outdid yourself.
I have in my imagination land, trying to focus. Right. If I use Euclidean geometry
That's child
to
abuse.
describe reality, I have in my imagination land, which is real.
It's inherent in nature.
Well, it's wrong.
It's not my problem if you don't want to learn. You just on your own.
I don't understand the doublespeak. I don't understand the contradictions.
I'm not sure that I would call myself a Dialetheist. I don't understand Dialetheism, because that's what logic is.
Yeah, absolutely foundational, right?
And there are different logics with different axioms. Well, it's by imagination, so I can just bend it in my imagination. I'm not sure that I would call myself a Dialetheist. I don't understand Dialetheism. Well, it's by imagination, so I can just bend it in my imagination.
Can you explain to us why they disagree?
That's child abuse. That's child
Because
abuse.
it turns out I can just bend it in my imagination. Space-time is non-Euclidean.
Well, it's wrong.
Euclidean.
Yeah.
One of Kant's
Don't understand.
well-known mistakes.
It's not my problem if you don't want to learn. You just on your own.
Well, if the current,
Pardon?
so if the plane is saddle-shaped, so I can just bend it in my imagination. If the plane is if you bend it, make it saddle-shaped, then
It's not a plane then, Brenda.
You think things are doublespeak, but that's because you don't understand. Well, if the plane is
wanna-
curved, so I can
Pardon?
just bend it in my imagination. If the plane is saddle-shaped, then
Plane?
that's if the plane is if you bend it, make it saddle-shaped, then
It's not a plane then, Brenda.
If that
This
wasn't
is getting old, Brenda. I mean, come on, you've got to do better than that. How you're not going to sell many globes talking like that?
so I can just bend
on.
it in my imagination. It's obvious to
Up
everybody.
your game, Brenda.
No, I have.
You're meant to be an expert at this, aren't you? Aren't you one of the best?
No, so I can just bend it in my imagination. Well-known mistakes.
Well, it's wrong.
I just understand.
It's wrong.
It's not my problem if you don't want to learn. You just
It's inherent in nature.
It's a description.
That's a quote.
That's what it is. They need Euclidean geometry to do all their stolen concept shit.
no reason, no logic. no wisdom, no worry.
As a front,
You're just on your own.
but in the back they're doing their magic globe shit.
No logic, no answers to question.
Their magic globe shit.
You're just on your own.
Yes, that's what logic is.
Yeah.
Absolutely foundational, right?
And there are different logics with different accents.
Reality, yeah.
It's inherent in nature.
It's a
That's a quote.
Transcendental, relating to the spiritual realm.
You read the second one, that's interesting. Very-
Kantian philosophy. Is that what you're after? You like a bit of Kant? Presupposed and unnecessary to experience a priori. I think you say that a lot. Is that a better way of saying it? A priori.
Oh, Immanuel Kant introduced that kind of language. Well, actually, people have been talking about it before that, but he was the big man in the block.
The old philosopher.
Come to find out that quote that I just spoke, it's inherent in nature.
Oh, was it?
Ah, yeah.
No way. Kant
Yeah.
said that Euclidean geometry was what's that?
It's inherent in nature.
Nature.
Inherent in nature, yeah.
Well, it's wrong.
That's a
Yeah,
tough
many
one.
people seem to quote Kant or whatever to saying that reality is obviously and clearly Euclidean.
Yeah.
That's child abuse. That's child abuse.
One of Kant's well-known mistakes.
Because I do actually
Yeah,
teach
it's-
my
it's
son
irrelevant.
geometry. So when you say we,
Yeah, that's child abuse. That's child abuse.
what, teaching my child geometry?
What? Yeah,
Brenda is in the house.
Yeah. With radians.
Do you have the pi symbol as your Discord avatar?
Yeah.
Yeah?
It's like
I just
rather
noticed
ironic,
that
isn't
now.
it?
Oh, that's fucking gorgeous, that.
Even though it's not a constant, it's okay.
Yeah.
Can't
'Cause
be.
that's what it is. They need Euclidean geometry to do all their stolen concept shit, but they, as a front, but in the back they're doing their magic globe shit.
Yeah, I didn't realize the absurdity of Brenda's symbol, huh? She argues non-Euclidean, but she has pi as a symbol.
Yeah.
It's beautiful.
I just noticed the symbol now.
How is that absurd?
Well, it
Oh
sort
yeah,
of
you're
goes
the
along with
non-Euclidean one.
Yeah, it goes along with the absurdity of Brenda. So it's completely fitting.
Yeah.
Sort of like, I would call that a flat Earth society-ism, or I guess you could call them globe Earth society as well. Same thing, right? Confusing people.
Yep.
Confusing you is not very hard.
Well, you've not managed to do it. We're just uncovering all of these contradictions.
All I have to do is have the pi symbol, and you get confused.
No, you don't realise the implications, do you?
What is the implication?
Do you put a value to that pi?
Yeah, I value it because it was sort of symbolizes a first encounter I had with a certain person like several years ago, maybe 3 or 4 years ago.
Wow.
That's why.
Nathan?
Nobody you would know.
Well,
Okay.
that would go to make more sense that you're not using it because of what the symbol actually represents then.
Yeah.
I still wouldn't see the problem. What's the problem with... I like mathematics.
Yeah,
I like mathematics. So
Do you go C over D, or do you assign a numerical value to it, which is of more importance?
what?
Yeah.
Assign a numerical value. I don't know what you mean by that.
What's the symbol you've got there, Brenda? Do you know?
It's an apple pie with the Greek letter pi written on it.
Yeah.
For Pi Day.
Uh-huh. So do you know what pi is?
Well, Pi Day, yes. pi is a transcendental number.
Do you know what that means?
So
Yes.
do you assign a numerical value to that?
Sure, I suppose.
Oh.
I don't know what you mean by that.
You don't know what I mean by assigning a numerical value to something.
Yeah, I
don't know.
To pi, because pi is a transcendental number.
Yeah, C over D. It's a ratio.
So do you know what? Yeah, it's a ratio. Yeah.
Okay. So
it's
more of a ratio then than a number, because that's not a number, is it? C over D isn't a number. It's not got a numerical value assigned to it. It's just C over D. Ratio.
Holy shit, you really are stupid, aren't you?
Oh, well, we may be talking past each other, Brenda. I don't know.
No, we're not.
Mm-hmm.
You think a ratio can't be a mathematical object?
A mathematical object.
That's what pi is.
A mathematical object.
Jesus Christ, you people are stupid.
Mm.
Ooh,
yeah, don't forget we're talking about Brenda and Contradiction City, so.
Yeah. Mathematical object. That's beautiful.
So you think that a ratio is not a number?
Well, I was saying, do you, Brenda, assign a numerical value to that symbol that you've done, or do you keep it as a ratio? It's very simple, Brenda. Very, very simple.
Pi is a transcendental number, so it is a number.
Yeah.
It is the number that you get when you put, circumference over diameter. Yeah.
Yeah.
That's a number.
Yep. Does it change? Is it ever differing?
No, of course not.
Oh. Are you sure?
Yes, totally.
Uh-oh. Thank you. Next.
There you go.
What are one of the different values of pi?
I mean, that would be ridiculous to talk like that, wouldn't it?
Yeah, can you imagine? Anyone thinking pi would have a different fucking value.
Yeah, imagine
Stupid.
thinking pi is not consistent.
I agree. It is a number, a transfinite number.
Transcendental, transfinite, mathematical object.
Yes. These are simple concepts, dude.
Yeah.
Right on.
A circle, fucking absolutely. Radius, circumference. Fucking brilliant. It's definitely Euclidean though, right?
It's a trigonometric function.
Yeah, that's Euclidean too.
Sure.
Mm-hmm.
Well, pi shows up in all kinds of places.
Yep. Definitely Euclidean. Thank you very much.
It shows up in other places too.
Pardon?
It shows up in all kinds of places.
Euclidean pi, yeah. Absolutely. Transcendental.
Nobody thinks of it just being Euclidean. It's just...
But it is, though, isn't it? I mean, like, it has to be, doesn't it?
I don't know what you mean.
Yeah, the ratio of the radius or diameter and the circumference, that ratio is particular to Euclidean geometry.
No, it isn't.
Absolutely it is. If you put a numerical value to it, absolutely.
You don't know anything about math, Bob.
No.
Well, yeah. Radius and diameter and circumference. I mean, that's definitely Euclidean, isn't it?
Pi shows up in all kinds of places.
Yeah, it's Euclidean. It's obviously reality. Yeah, that's why it's there. Because it's transcendental, isn't it?
Yes,
yeah.
It is.
Yeah. Euclidean must be transcendental too. You'd think, wouldn't you?
No. What are
Why?
you talking about?
What do you mean? Who? What? No way. Yes. Did you ever study mathematics, Brenda? Do you ever do any geometry? I mean, I know you don't think Euclid is relative to reality, do you? It's weird that you think pi's transcendental.
That is
Hmm.
a bit odd.
I don't understand. You don't think pi is a transcendental?
You don't understand. You don't understand pi, do you? Or do you? I mean, it's nice that you've got it as a symbol. And it's definitely Euclidean, isn't it? That ratio of the diameter to the circumference.
Definitely consistent.
Hmm. What does transcendental mean? Brenda, did you just make that up? So you could get trans into something. Do you want me to Google it?
Excuse me. No, I don't have to. So transcendentals are non-algebraic numbers.
Mm-hmm. Yeah, because algebra's letters and numbers are numbers, right? So I would guess, is every number a non-algebraic number? No. Which are the numbers that are algebraic?
What?
Which are the numbers that are algebraic? So I can make a note.
Like the integers.
Which ones?
Natural numbers, integers, whole numbers. Right?
They're all algebraic.
Rational numbers, yes. Pi is an irrational number.
Mm-hmm.
Which means it's non-algebraic.
You mean the Euclidean pi? Because you don't know about the other ones, do you?
Nobody talks like that. That's just nonsense.
Well, you can't speak for the non-Euclidean pies, can you? You only know about the Euclidean pi, don't you?
I don't know what you're talking about.
The one you've assigned a numerical value to. There's a direct ratio between the... I mean, it's all right as a ratio, because then you can get away with it, but the moment you assign a numerical value to it, then you are assigning Euclidean.
I still don't know what you mean by assign a numerical value. I don't know what that means.
No. I know. You don't know what numbers are, do you? The algebraic ones.
Or either one. Yeah.
Do you know what the algebraic numbers are? Or the actual numbers that we all use?
I told you.
Mm-hmm. Because just saying C over D, circumference over diameter, that's not really assigning a numerical value to it, is it? It's keeping it as a ratio. Because that's what pi is. We get everybody to learn a bit here, Brenda.
You can truncate
pi.
You can truncate it to, like, say, the last 4 digits or something, which is what people usually do, right? When you're making an actual calculation, you just expand it.
Mm-hmm.
You know, the last 4, no, to the first 4 digits right after 3. Yeah,
right. So you have, like, you said 3 there. So that's a numerical value. So you do know what assigning a numerical value is to that symbol then, right?
People just use, 3.14, a lot of times people just use 3.14.
Yeah.
Depends on the degree of accuracy they want. 3.14 or 3.1415, right?
Yeah, but the moment you do that, you are definitely assigning Euclidean geometry to your calculation, right?
I don't know what you're talking about.
You don't know. I know it's tough. Can we do our best? Right. That symbol that you've got is your sign. It's pi. It has a ratio. It is the ratio of the circumference of a circle
to the
diameter of the circle. Right. Now that circle that you have just described there is Euclidean, because it's a two-dimensional circle on a superficies with the ratio of that circumference to that diameter. Now, yes, but the fact that triangles are formed within a half of that circle along the diameter, really, and that's the way we can do it. The relationship of the circle to the triangle, as you know, all triangles can be circumscribed, right? That's also Euclidean. So that goes to show that very circle is related to the triangles of 180 degrees, or the sum of two right angles, directly. That's Euclidean. The moment you put a numerical value to that pi, you are definitely talking about Euclidean. And you, like you say, you only know one value for pi, so that's really handy. That must be then Euclidean geometry. We all can just sort of go, well, that's that sorted. Thanks a lot. We're just Euclidean. I don't know why anybody else would ever talk of any other geometry. I mean, what's the point?
If you, absolutely, you need much more. Yes.
Mm-hmm.
Progress beyond, like, say, junior high school. Yeah.
Mm-hmm. So where does pi change then? That you know of? When was the last time you heard of somebody changing pi?
It doesn't change. I don't know what are you talking about?
Okay. So it means that we just must be in Euclidean 3 space, right?
How does that follow?
How does that follow?
Yeah.
Because that's what you use for your value for pi. It happens all everywhere, you said.
Because pi, therefore we live in 3
Euclidean.
space?
Yeah.
That doesn't make any sense.
Yeah, it does. Makes absolute sense, doesn't it?
What's the argument?
The argument is Euclidean geometry. Is the geometry used in reality with parallel horizontals and perpendicular verticals? Shortest line distances being a straight line, i.e. Euclidean.
Yeah, this is just you make a religion out of Euclidean geometry.
No, we're just talking about how we describe reality, Brenda.
Oh, we can use lots of other things to describe reality.
Brilliant. I think Euclidean is the best mathematical way of us keeping it to an exactness. Like you don't want to start messing about with pi, do you?
If I describe something, do I live in the description or the thing I'm talking about?
I don't know.
You don't know?
Well, how do you define the circumference over the diameter? And is it important? I wouldn't. How important is it anyway? It's only because you had it as your avatar, and we just thought it would be good to bring a conversation about it.
If I use math to describe reality, which is real, the description or the thing I'm describing?
Well, the thing that you're describing is Really, you saying people have got things wrong?
That wasn't the question.
Okay.
Try to focus.
Well, the description is meant to do its best to describe something in reality, right? And pi does that very well mathematically with a number and a ratio.
Could I use maybe other things to describe reality?
What would you use to describe pi?
Just something else.
Yeah, other than like a symbol, a ratio, or a numerical value. You wanted something else now as well. But not a different numerical value.
Try to focus. Right. If I use Euclidean geometry to describe reality, which is real? Reality or the geometry?
The geometry, if it is failless, right? If you can't fail the geometry, then it's doing a very good job for describing reality, right? Because that's all it is a descriptor of reality.
I could have a map that does a very good job of describing where the cities and roads and trees and mountains.
Yeah, 2-scale maps, they're very good. I've got them.
But which is real? Which is real? The map?
The map's real as well. I've got one. They're definitely real.
Which is real? The map?
The maps.
Or the territory?
Both of them. Both of them are real. The map's definitely real. And the land that was measured is definitely real. All of the measurements that were made are definitely real. And they would have to be checked as well, because putting them on a map would show any inaccuracies in it, wouldn't it?
Do I live on a map, Bev? Is that where I live? On a map?
I don't know.
You don't know.
What's your carpet like? I don't know.
You don't know whether I live on a map or whether or not I live in the real world. Which is it?
I'm not so sure you live in the real world. But, I mean, I don't know. Like I say, I don't know what your carpet's like.
Where do I live? Do I live on the map?
I don't know. I don't want to know where you live, Brenda. Don't be trying to...
I know you need
to
avoid this. Because you realize now you made a mistake.
Sorry?
That's rich.
Yeah.
Brenda, you don't think the map is real? Because that's all Beth said. The map is real. He has one.
Rakia, where do I live? Do I live on the map or do I live on the tip?
We don't know where you live, Brenda.
No, that's not the question. So
yeah, you asked where do we think you live?
No,
we have no idea where you live.
That's not the question.
Well, maybe it's a malformed question.
No, it's not. It's actually a question that quite a lot of authors like Nathan.
Why are you bringing other people into this? I asked you a question. Do you think maps are real?
No, the question is...
Are maps real?
Is which is more real, the map or the territory?
He answered that already. They're both real.
No,
the land is real, and the map that it describes is real.
Where do I live? Do I live in the territory?
We don't know where you live.
Yeah,
this is getting old, Brent. I mean, come on, you've got to do better than that. How you're not going to sell many globes talking like that? Come on.
So it's obvious.
Up your game, Brenda.
No, I have.
You're meant to be an expert at this, aren't you? Yeah. Aren't you one of the best?
No,
you're not one of the best.
Let's just go over it again. We have no idea where you live. We don't want to know where you live. Maps are real. Maps are real, and the land that they're describing in reality is real.
So Beth, it sounds to me like Rakia is model afflicted.
Really, Brenda?
Yeah.
Like I'm struggling to understand what's going on here, Brenda. I mean, there's a lot of people like this that you don't seem to hear. You seem to be having a different conversation.
Yeah,
like,
you do
struggle. Like, what's the point of you coming round here and like having a different conversation?
I don't know what you mean.
Well, there you
go. He means you avoided his pie question. You moved on to, do you live on a map? Which is ridiculous.
Yeah.
To even ask.
Well, we covered pie.
You go back to answering the pie question.
Well, it's really
pie in your reality.
I'm sorry, what?
Can you change pi in your reality?
No, of course not.
So it's Euclidean then, right? The reality that you live in is Euclidean because
it's not Euclidean. It's transcendental.
Okay.
Wow.
You can't beat that. Like you can't beat that. It's delusional.
Yeah, that's fine. I'm delusional.
Or you're just traveling in circles. Like you're saying whatever word you want to say to make it sound good to you. It doesn't make any logical sense.
Pi doesn't make any logical sense to you.
If that's how you twisted that, you are delusional. If that's how
you broke Brenda. I mean, this is hard work. This to realise that pi that you love so dearly, Brenda. Obviously, you've got fond memories of pi, and we may have just wrecked it.
Oh, really? How did you wreck it?
Well, you don't think Euclid's real, and you don't think the geometry of Euclid works, yet the very thing that you're carrying around as your avatar is pi. If you assign a numerical value to it, you are assigning a Euclidean geometrical value to that ratio. And that is in reality. That's reality.
Well, for one,
like,
I do think Euclid was real. He lived a long time ago, but he was definitely real. So that's not true.
Not the man. The geometry, you fool.
Yeah,
are you?
It doesn't matter. He doesn't know. It's all right.
It's a simple question.
Yeah.
So the geometry, Euclidean geometry, is a formal system created by humans to help them describe the real world.
Reality, yeah.
It's inherent in nature.
Yeah.
That's
a quote.
Yeah. It's a description. It's not the thing described.
It's inherent in nature.
Is there a difference between the things we talk about and the way we talk about them?
With you, it is.
Transcendental, relating to the spiritual realm.
Yeah,
Transcendental, maybe.
Yeah, but you read the second one though. That's interesting.
In
Very
Kantian philosophy, is that what you're after? You like a bit of Kant?
Yeah,
presupposed and unnecessary to experience a priori. Oh, I've heard QE say that a lot.
Yeah,
is that a better way of saying it? A priori.
Well, Immanuel Kant introduced that kind of language. Well, actually, people have been talking about before that, but he was the big man in the block.
The old philosopher.
Come to find out, that quote that I just spoke was actually his quote.
Oh, was it?
Ah, yeah.
No way. Kant said that Euclidean geometry was inherent to nature.
Inherent in nature, yeah.
That's a tough
many
one.
people seem to quote Kant or whatever to saying that reality is obviously and clearly Euclidean.
Yeah.
One of Kant's well-known mistakes.
That was great.
Wow.
That was good.
Go on, Brenda. Give us some more of your wise words.
Tell us how brilliant he is, and then tell us how many mistakes
He's the big man, but he made a mistake. It's okay.
Yeah. That one's a mistake, obviously.
That's just how things are. Humans are fallible. They make mistakes.
Yeah. We're talking to you. That's right. We hear you. You're making many mistakes.
So somebody can be a genius and make significant contributions and still make a mistake. Yeah.
And be corrected by Brenda.
Yeah.
Yeah. Just doesn't add up, does it? Something just doesn't seem right in that statement. This guy is brilliant. He's the man. Everyone agreed with everything he said. It makes logical sense what he's saying.
No.
But Brenda is correcting him.
Yeah, wait a minute. It links to pi as well. It's also backed up to pi, to like the inherent in nature. But Brenda says he's wrong. But we're sticking with pi as well.
Part. So I'm just going to go out on a limb and say the last part where Brenda is correcting him is the illogical part, like the part that doesn't make sense.
I'm not correcting him. Other people did because other people didn't agree with him, right? That's
Other people like you.
I'm just as like say a student. I just understand why they disagree.
So it's a consensus thing?
Can you explain to us why they disagree?
Right, because it turns out that the geometry of space-time is non-Euclidean.
Okay. This is super. Wait. This is super rich right here. Say that again. Space-time. What was that?
As it turns out, Kant was wrong. The geometry of space-time is non-Euclidean.
Wow, Brenda.
Oh, well, then you need to rethink your whole pi argument from earlier.
No, it doesn't.
Well, you don't have to go there just yet. Just admit that Kant is talking about Euclidean, and then you're going to non-Euclidean to prove him wrong about his Euclidean statements. That doesn't make sense, does it?
That's
this
true.
Is way beyond.
You're a moron.
What?
Space-time geometry, ladies and gentlemen. This is new stuff.
Yeah, but it's non-Euclidean. So if I make a statement about a triangle, Euclidean geometry, then that statement should stand on its own, very separate from your conceived idea of space-time geometry. That's a completely different issue, isn't it?
Yeah.
Yeah, exactly. So how can you take a concept completely removed from the concept that person is talking about in order to say that he is full of shit with what he's talking about when you're talking about something else?
I didn't say it's full of shit. I said Kant was simply wrong about this one thing.
What thing?
His claiming that the real world is obviously Euclidean. He was wrong about that.
Well, he was obviously correct about that because non-Euclidean space-time, as you call it, is non-Euclidean. How does that relate to reality?
Can we not forget she gave pi as being transcendental? And when looking up the definition in Kantian philosophy, but she says Kant's wrong. So were you wrong about saying pi is transcendental?
No. Pi is a transcendental number.
Yeah, but that's what your guy that you said is wrong now said.
So?
Post-diletheism, Kant.
Maybe they're both wrong and right, huh, Brenda?
See, you approach this completely wrong. It's like you have these fan clubs, and you're like in the Euclidean fan club. And
Why do you think it's us?
Huh?
You're in the fan club of just saying whatever you want, taking bits and pieces of whoever you want, and going, voila, this is my reality, but I don't really live in reality, and I'm going to ask questions like, do I live on a map? Why should we even listen to that?
That's good.
You realize you asked that question like 10 times, right? Do I live on a map?
Because you didn't get it. You don't understand.
We answered it every time. We don't know where you live.
Yeah, that's not the question, though.
That was the question. You asked very specifically, where do I live? On a map or in reality?
I know, but that's not the question.
Jeez. I'm sorry I brought it back up.
I understand, right?
You're going to ask it again, really? After I actually ridiculed you about it?
This is more than 8th grade geometry.
This is fucking killing me in the background, guys. You just keep this going. I'm fucking loving every minute.
It's great,
Brenda,
isn't it?
I like you. You're pretty cool.
You have to get ready for the post-diletheism Kant. It's a new philosophy, isn't it, Brenda?
I'm not sure.
I'll be trans before long.
I'm not sure that I would call myself a dialetheist. I don't understand dialetheism.
It's not that. It's just an axiom you inject into anything wherever you want. You can switch it on and off. It's all right. It's very doublespeak orientated. I think you already do. I mean, whether you know it or not. I mean, who knows?
You think things are doublespeak, but that's because you don't understand them.
I don't understand the doublespeak. I don't understand the contradictions. Or I just see the contradictions. I mean, that's...
There's no contradiction. What contradiction have I
Well, there you
about?
go. Well, no, I'm saying, when I look at things and see contradictions, you don't seem to see them. And that's I mean, what is that?
What is that? That's you not understanding.
The contradiction or what? I don't understand, Brenda. Please.
So I know. I don't know how to make you. I can lead a horse to water, but you can't make him think.
Why is it always someone other than you, Brenda? Like, why is it always Bev or me? Do you think every now and then, like right now, it's you not understanding?
No.
Like this very moment. Could you ever admit to that?
It's not my problem that you don't want to learn.
Yeah, me and Buster just pointed out two separate contradictions to you. you were having both of them, like, no problem.
What's the contradiction?
The value of pi, obviously, and how Kant's Euclidean statements were thrown back at him using non-Euclidean, logic.
Well, focus on one, the value of pi. I agree with Bev that pi is the ratio of circumference to diameter. What's the contradiction?
You think it has to do with Bev?
No, what's the contradiction?
No, in reality, there is no contradiction. It's just when you want to talk about pi and go outside of Euclidean geometry, obviously. So that's where the contradiction comes in, because pi is Euclidean, right?
You said I asserted some kind of contradiction. Please name it, or shut your mouth.
Yeah, I specifically named the one.
Brenda. It's okay.
Yeah, I specifically pointed out the contradiction of you saying Kant was obviously wrong. But then you also said the reason he's wrong is because somebody from a non-Euclidean standpoint told him off while he was making Euclidean claims. That's that's a contradiction.
That's not why. And it's not a contradiction.
What's the problem with it then, and why is that not it?
If I disagree with somebody, is that a contradiction?
No, that's a disagreement.
If somebody says something that is wrong, is that a contradiction?
Depends if it is a contradiction or not, right?
It's contradiction with what you were saying he said. Like, you're saying he's right about this, and then you're contradicting yourself by saying, no, we're not using Euclidean now.
Immanuel Kant said that reality is Euclidean, right?
Yeah, which it clearly is.
Which he is wrong about.
And how so? Oh, non-Euclidean geometry, which you cannot verify in reality. So how do you conflate it to reality?
But we did. We have verified it.
Yeah,
Brenda,
elaborate on this.
Is pi involved in space-time geometry?
Pi is like everywhere. So yeah, I would imagine it's found in equations.
Brenda, you shouldn't have answered that one.
No, that was a bad one, Brenda. You just agreed it's Euclidean, and now you put.
But I have a follow-up. Can you explain us this space-time geometry, please, Brenda?
Right, space-time, right, is a measure of distances in the world.
So you mean Euclidean?
Yeah.
No.
Well, how do you incorporate time into space? Like, please explain this.
Right. So space-time is the fact that length, breadth, and time are needed to fully describe reality.
Length, breadth, and time.
Yeah.
2D plus a clock.
Yes.
Yeah.
2D.
How so, Brenda?
What? Where did we lose a
we have
dimension?
2D and a clock.
Yeah, that's my
Well,
question. Where
wow.
did we lose the third dimension? We're definitely living in 3 dimensions.
I said length, breadth, and width.
Oh.
Oh no, no, you didn't. But that's okay. Go on.
Yeah.
Just
Put it back
obviously.
in. Take a mulligan.
That was just a
Just a mistake.
Yeah.
So
Yeah.
X, Y, and Z, not X, Y only, and the clock.
X, Y, and Z plus time. Yes, that's what space-time is.
But isn't it a fabric in your imagination and your fantasy? Isn't it like kind of a fabric that bends and shit?
Yeah, we need the three origins, right? X, Y, and Z.
That's
plus
not a
time.
geometry, though, is it? You can't just add time in to it. I mean, because time, when Euclid did his geometry, or, you know, that group did that, they were trying to describe reality with the geometry.
It turns
obviously time was around then, wasn't it? I mean, it didn't figure into that geometry that we use.
out then, but it does now.
Yeah, but how did they do that? Where did they squeeze time in to geometry?
Where did they put the T in? Yeah. Where was that T introduced?
They used a higher level math than you are capable of understanding.
Okay. What, to add in another dimension somewhere?
Yeah.
Perpendicular to the other 3.
You can barely understand Euclid, let alone anything.
Yeah, obviously.
So they took our reality, X, Y, Z.
Did we keep pi though?
Pi is a ratio.
Yeah, pi. So pi always stayed the same, even though you shoehorn time into geometry at some point in the history. Do we know when?
Pi is not in the definition of space-time, right? But
So when you put the T in, you can curve the straight line once you introduce T.
You change the ratio, don't you, of the radius over the other's diameter over the circumference, don't you?
That things travel along geodesics. That's how.
So it's the T that bends the straight line? It's the T?
In a non-Euclidean geometry, a geodesic is a straight line.
So the T does that. When you introduce the T in the equation, it bends the horizontal somehow, or trying to get my wrap my head.
T is one of the dimensions.
In reality, Brenda, a straight line is a straight line. So a geodesic is a straight line in.
Yeah.
Okay, and you say a geodesic is a straight line in not Euclidean geometry.
Here you go. A geodesic is a straight line in reality.
Mm-hmm. Oh, cool.
Shortest distance between 2 points.
Absolutely.
That's brilliant.
That's
so that's
good,
Euclidean. Yep.
What?
Either one.
No
Either
way.
Euclidean or non-Euclidean, a geodesic is still a straight line.
Good.
So you're attempting to build a fantasy model, non-Euclidean, but still use Euclidean all the way through, correct?
Seems like you got a straight line that's the same. Pi's the same, so the ratio of the diameter to the circumference is the same. It doesn't seem like it's very much fantasy, other than Brenda's imaginings that she thinks Kant's wrong about some shit.
So
that she agrees with him when he was correct about it. Like when he, like you know different, Brenda.
So Euclid is a fantasy model. Bev is model afflicted.
Wait, Euclid is a fantasy model. Have you read the book? It's called Euclid's Elements. It's really good. You should give it a look over.
Yeah. So Euclid is a fantasy model.
Yeah, please don't be model afflicted like Brenda. Please.
Bev, you are model afflicted.
Euclid is fantasy, but space-time geometry is real. Wow, Brenda, you outdid yourself.
We shoehorned time in at some point. Euclid stopped being real. Stop being. Was it real before you shoehorned time into it, and that made it not real, or was it never real until you shoehorned time into it and then made the real
None of math is real. Math is just a system of a way of talking about reality.
Geometry is a measurement of the earth, right?
Yeah,
Actually, in reality. So that is real. Like that is when you go out and measure in reality, you are actually performing real life geometry. It's very good. We're doing a series, Brenda, called Realizing Euclid.
You are model afflicted.
It's called Book 11, Solid Geometry.
When you measure something, that's a description.
Shortest distance between 2 points is definitely a straight line.
You reify Euclid.
By measuring a straight line in reality.
Yes,
nice.
Measurement.
That's not how you prove it, surely.
Measurement is description.
Yeah. And then we've got all sorts of numerical values that we can put to them, and different measurements that we can assign to them, can't we? All in reality.
Dev is model afflicted.
Space-time is complete fantasy nonsense.
Okay.
Yeah, so is Euclid. Complete fantasy.
No, but yeah, space-time, yeah. No, but we go out in reality and actually do measurements. Let's say you measure your floor, you get a meter right across the floor.
That's a description, isn't it?
Yeah, the meter is arbitrary, obviously.
Is the description the same as the thing that you're describing?
What?
The distance length is the distance length. If you want to put a meter or a foot or a yard or whatever, that's up to you.
Is the map the same as the territory?
A piece of paper.
Is the map the same as the territory?
Are you talking about specific piece of paper?
She got stuck again. Give her a nudge.
You just don't
done this one. Done this one before, Brenda. It failed last time.
Yeah.
Just forget about it. Carry on.
Because you reify the math.
So if I do a measurement of distance, straight line distance in reality, like let's say I was going to draw up a blueprint. I want to build myself a little cottage in the woods, right? And I need to do measurements. I can't just simply scale those measurements down and put them on a piece of paper? Geometrically, of course.
Do you live in the measurements or do you live in the cottage?
Well, the measurements are done in reality, yeah.
That's not the question. Why don't you ever answer the question?
Live in reality, do measurements in reality, and then I scale those measurements down and put them on the piece of paper. Of course, I don't live in the piece of paper 2D representation I made. I did the measurements in reality, Brenda.
Yeah, there's a difference between what is real and the description of what's real.
Yeah.
The real life distance measurement that I made in reality, that's definitely real.
So do you agree with me that there's a difference between the description and the thing described?
Do you know what describing a circle means?
And now you're just equivocating. So
no, I'm asking you if you know what describing a circle means.
You're desperately trying to change the topic. Is there?
You know what the word describe means?
Is there a difference between the description and the thing described?
If I describe a circle on a piece of paper, then definitely that circle on the piece of paper there is what I described perfectly.
Yeah, you're just broken.
Exactly.
I'm broken. Okay.
Yep.
That was very good. Well done. Thank you very much. Learn from that one. I think that was a good one, Brenda. Like, yes, we know there's a difference between the thing being described. I mean, we're the ones that deal with the law of identity, right?
And Euclid.
So the identity of the thing that's being described is that thing. But if you draw a picture of it, the identity of the picture is a picture of that other thing that has its own identity, right? They're not the same thing. We know that, Brenda.
Yes, but so
you might be struggling with it, right? But so can we get it certain that when we're talking about things, we are talking about things in reality, and we do our best to describe them.
Yeah, Euclid is the description, not the reality.
Uh-huh.
Right. So Euclidean geometry is not reality.
Well, the shortest distance between 2 points is a straight line.
Yeah, that's a geodesic.
Just like Euclid described.
And non-Euclidean geometry. It's a geodesic.
Well, no, the definitions are within Euclid, are for these things. Do you have a source for the definitions within your geometry that you want to be using? Do you have your Dialetheist's definition book?
So again,
I'm
not convinced that dialetheism is quote unquote.
Okay. Do you have the not Euclid definitions?
I've been telling you about.
Or would you be using stolen concept and just be using Euclidean definitions mentally, right? To think that you can just inject your dialetheism into the geometry without bothering about any of the definitions.
Dialetheism has nothing to do with this.
Mm-hmm. Well, in your definitions of your not Euclid or not Euclidean geometry, do you have a definition for a square? Or would you just stolen concept Euclid for that?
I don't know what you mean. So why do I have to stick to what we mean? Why can't I use Euclidean geometry when I want to, or non-Euclidean geometry when
Dialetheism, you can do that whenever you want. It's obvious that that's what you've been doing.
So
you can just switch one of them on and the other one off whenever you want. Like, obviously, because I mean, you can do that with reality, can't you?
Because you're model afflicted, Bev.
Mm-hmm. Yeah.
Can you give us a brief explanation of non-Euclidean geometry, Brenda?
It is where they take Euclid's postulates as 5 axioms, right? And then they just change them.
Just change them a little bit. Okay, got it.
Axioms. They just change axioms.
Yeah. We're allowed to do that.
Who's
undeniable
truth?
Who's you're allowed
to do that?
You're allowed to change
Who
undeniable
granted you
truths,
permission, Brenda? Who granted you permission?
I did.
To just change.
Yeah, I did.
Mm-hmm. Yeah. Dialetheism.
Yeah. Rumpus says the same thing. He also says like he's free to define whatever he wants, says whatever he wants at any moment he chooses. It's really brilliant.
Yeah.
Math is just a tool, and I can use whatever tool I need to do the job.
It's like a superhero power, Brenda. You've given yourself. It's like it's one of the best superpowers anyone could ever have. In fact, I don't even think there's a superhero with that power. You could be literally inventing a new superpower.
Change reality. Activate.
Reality change, man. Poof.
Yeah.
I'm trying to think about
okay, I gotta come in here now. Technically, Thanos can change reality with the fucking reality stone, but
yeah,
I
no,
wouldn't put
Brenda just
on
does
the
it
same level as
on
Thanos. He's
Discord.
way too cool.
So
I
again,
was gonna go there, turn up. Actually, yeah, with Thanos, I wasn't gonna use him as the example, but the very same example. They're still stuck to Euclid because they're talking parallel universes.
So you're
Not even all the universe rings or whatever they're called could do that.
You're model afflicted. You think fantasy is reality.
Brenda, stop with the projection. It's getting a bit too obvious now.
No, I'm fine.
We're telling you to please stick in reality.
No, I'm comfortable with what I've said so far. Everything I've said so far, I don't feel any problem with anything I've said.
Even changing undeniable truths at will.
Absolutely.
That's comfortable.
Good.
Wow.
Did you ever go through all of the 12 axioms in the elements one by one and think about them logically if they actually make sense or not?
Really,
Before you start changing them around, you want to make sure they're actually good as they are, right?
I'm sure actually they are good. They're just fine. They're very good axioms.
Ooh,
Wow.
all of them.
Which
right?
axiom would you change first, Brenda? I'm curious. Which axiom would you change?
And which
The fifth-
one would you change the most?
With the fifth one, you can get either spherical geometry or non-spherical geometry.
Yeah.
So you'll make a triangle axiom a parallel.
Boom!
Parallel.
You
Change it.
explode it.
Wait, what? Are we talking about when equals are taken from unequals? What are we talking about, Brenda?
We're talking about which axioms in Euclidean geometry.
You said number 5. I'm asking, isn't that the one of equals being taken from unequals?
No. Number 5 is the fifth.
Yeah, number 5 is number 5. Yeah.
Yeah, it's a parallel axiom.
No.
I don't think the word parallel is even used in none of the axioms.
It's the 12th axiom, Brenda. The 12th.
No, if
That's number 12. Yeah. If you want to talk about the triangle axiom, that's number 12.
there are different editions of Euclid, and they have numbered differently.
And they what?
I said there are different editions of Euclid, and the different editions number them differently.
Are you sure all of the new different editions even include all the axioms?
There are different
all 12 of them.
There are different editions, and they're numbered differently.
How many axioms are there, Brenda?
There's 5.
12.
I have 12 in mine, yeah.
Yeah. There's 12 in my book as well, Brenda.
You can prove...
How many have you got in your book, Brenda?
Right, so it doesn't matter, all of this.
Do you have a copy of Elements there?
Axioms doesn't matter. Logic is at the foundation of the axioms, right? Surely logic has to be a part of an axiomatic system, right?
Yes, that's what logic is. Yes.
Yeah.
Absolutely foundational, right?
And there are different logics with different axioms.
Yeah, that's not what we're talking about, though, is it?
That is what we're talking about. We're talking about logic.
Yeah, the 12 axioms in the elements.
No, that's not logic. That's geometry.
That's not logic.
What? Brenda.
What you...
Geometry. Euclid is about geometry. Logic is a different thing.
If equals be taken from equals, then the remainders are equal. That's pure logic. Two things which are equal to the same thing are equal to each other. It's pure logic, law of identity.
The whole is greater than the parts.
Yeah,
logic.
Is a point logic.
Of course it is.
How is a point?
Without logic,
it's a definition, not an axiom. It's a definition.
Yeah, that is true. But I'm saying the point wouldn't be a thing if without the logic needed to.
Logic is a line logic. A circle, is that logic?
Yes. Once you place it into the axiomatic system of Euclidean geometry. Yes.
So logic is a different discipline.
It's pure logic, Brenda.
Yeah.
Is discrete mathematics. Right? Discrete, yeah.
You'll kind of like have to go behind the corner or hide when you're drawing straight lines.
Right.
Really discreetly draw the straight lines in hidden secret.
Discrete, not discrete.
How many geometries do you know, Brenda, that actually make it into the third dimension, into past 2D?
There's Euclidean, non-Euclidean.
What? Which is the non-Euclidean 3-dimensional geometry that you know of? And where would we be able to see this geometry in effect?
Yeah, hyperbolic.
Where?
I told you, hyperbolic.
Yeah, where would we be able to see this? A 3D hyperbolic geometry, you say?
In the real world, you would see it.
Where?
Right? In the descriptions of gravity and space-time as it is bent by gravity.
Do we have to throw your own question back at you? Is the description the same thing as the thing you're talking about, Brent?
Yeah, he asked where we would see it, and that's how
you went to a description, right? So is the description the actual thing you're talking about? That's your own question from earlier,
The
Brenda.
actual thing we'd be talking about would be how things are distorted by gravity.
Go on.
Is the thing you described the same as the thing described? Is the description the same as the thing? Sorry.
Hyperbolic geometry is not the same, right, as reality.
Okay, well, that's good.
However,
you did say it was in reality, though. So where would you find that?
It's a better description of reality than Euclid.
It's better.
What?
Do you have like the book on hyperbolic geometry with the author's name and all the definitions and axioms and all, or do you just add it on as book 16 to Euclid? Like, what's going on?
So, general relativity.
So no book then, just
no way.
Piecemeal of all sorts of people, right?
General relativity utilizes a non-Euclidean geometry to describe the world, and it's a better description. Yeah, it's a better description than
Is the description the thing, or is the thing the thing? You're just saying it's a better description. You've got a better description of Euclidean geometry. Even when we say, like, in reality, when we're measuring a distance, we call that a shortest distance, and it's a straight line.
So your mind
is that does sound like Euclidean. So can you just give us your better description of the shortest distance between 2 points?
That would be a geodesic.
Right, and what's a geodetic?
The shortest line between any 2 points.
A straight line.
Same thing.
Yeah.
Necessarily.
No better or worse. It was literally
so you're just using a different word. We could just use geodesic instead of straight. For some reason. I don't know why you want to do that.
It's more.
I think you broke up then.
It's a generalization.
Why do you want to generalize straight? How do you do that?
Yes, that's what a geodesic is. It's a more general concept
than straight.
They were the very same concept you just told us.
Yeah,
more general than a straight line.
Yeah, but straight is
straighter than straight.
Is the
straight?
How do you generalize a straight line? It's like a mean length or something, like a mean straightness.
Yes. Well,
how do you generalize it? Over length, thickness? Like how do you generalize? Go on.
It's more generalized in how it is used in different geometries, right? So a straight line is a geodesic on a flat plane.
Straight.
On a flat plane.
Can it curve?
What? Is there any other sort of planes, or are you just sort of generalizing, putting flat onto a plane? Because
if the plane is curved,
pardon?
So if the plane is saddle shaped,
the plane.
If the plane is if you bend it, make it saddle shaped.
Then it's not a plane, then, Brenda. It stops being a plane.
Not even Thanos can do that with the universe rings, like we went over earlier.
Yeah, this is one of the best superpowers I've ever heard of. This is great.
A curved plane.
Yeah.
And it's curved in both directions at once. Don't even try it. It's a double curve.
You're getting confused between concepts and ideas and reality.
Yeah, you're getting confused between crisps and geometry.
Pringle and flat plane. Flat plane.
Yeah. If you take a flat plane, the straight line is a geodesic, and if you bend it into a saddle shape, that straight line is
It
now
won't be straight.
it's
Not
still
straight. The
geodesic.
plane isn't a plane, and the straight lines aren't straight. Yep.
That's because your model afflicted that.
No, it's because you bent it. The moment you bent the plane, that was you that did that.
No, I'm not talking about. This is the description. This is the math. We're not talking about what's real. We're talking about the math.
Oh, okay. So you just a description then, right? When you want to say we have to separate the description from reality, we're definitely doing that now, right? You're just painting a picture in your mind that we can imagine that you might end up being right about this, Brenda.
Euclid is just painting a picture in your mind.
No, we can use that. We can get proofs in reality, definitely.
Yeah.
I mean,
that's
there's no denying that, Brenda.
All based on logic from the very beginning.
Euclid is painting a picture in your mind. That's all it is. It's a fantasy. It's an idea.
Brenda, does the plane bend with distance in your mind or with the addition of the t, the time?
It just depends on how you label the axis.
Right? Well, you have a plane, right? You have a plane. When does that plane start to bend? Or how? Is it because of distance? Or is it because of time? The fabric thereof?
I don't know what you mean.
Well, you have a plane, right? We can establish that we can make a plane, horizontal plane.
I have in my imagination land, I have a plane. So yeah, go ahead.
Okay, so you have a plane. Now, when does that plane start to bend?
Well,
for what reason?
It's my imagination, so I can just bend it in my imagination.
How about if we bring it to reality now? We take this plane and we bring it to reality.
There's no planes in reality.
We can't make a level plane in reality?
There's no planes in reality.
You're kidding me, right? We can't tell Rakia, give him a contract, make me a plane of 2 miles squared, let's say. We can't do that.
Will it be two-dimensional?
Obviously not. It's in reality.
Right. So that's not a plane then, is it?
So we can't make a level surface in your mind in reality.
That's what I said. You're changing the words now, right? Planes are two-dimensional. Reality is three-dimensional. How can you put something that's two-dimensional in a three-dimensional world?
Three-dimensional.
So there's no way to level a surface in your mind in the real world. There's no way to.
What?
You call it a flat plane. You did before. Yeah. Just call it a flat plane. You put it in reality then, don't you?
If you level a bit of ground, right? Is it
level? See, that's in reality. Definitely. There you go. That's the way you
level,
get
ground. Yeah.
Just use level instead of plane, right? The level surface. How about that?
Let's say I want to make an airstrip, right? A long one.
I lay some.
Let's say for the ISS to land, right? We need a long surface, right?
Well, the ISS, when it lands, it's just going to make a hole. It's not
make a hole.
Yeah, it doesn't have any wheels, dude.
That's
sorry, did I say the? My bad. I meant the space shuttle. I misspoke there.
Okay. Yeah.
So we want to make a plain, flat surface for the space shuttle. Let's say 2 miles. Can we achieve that in real world?
A strip of concrete, right?
We can do that in the real world?
Make it level? Of course you can.
Okay, now, in your imagination, where does that start to bend? Is it because of the length? Or is it because the additional T that you put into your fantasy?
Level just means at equipotential to the center of the Earth, to the Earth's gravity. That's what level means.
So then that surface that we agreed upon, that the space shuttle will land, is curved. We made it level, flat, but it's actually curved in your mind.
What level means. Level simply means conforming to the curvature of the Earth. That's what it means.
So there's no such thing as a level surface in reality for you.
That's what level is. So yes, it would be level.
So you wouldn't have to do anything to the land beforehand. A mountain is a level surface.
Level it, of course you would.
See, look,
Just have
I've
it
put
land
it
on
in
a
there.
mountain.
Euclid must have wrote it in his, disguised it in his postulates. I'm not
There's
surprised.
no
What?
word. Level is nowhere in Euclid's postulates.
There you go. Postulate number 3. And that a circle / level may be described from any centre at any distance from that centre. That's what you just did.
It doesn't say level.
It might as well do, though, right? That's how Phil Bell describes it, level. That's how
In
you've
there.
just described level.
So it's not in there, is it, Bab?
You think it's a circle, though, don't you? Level. Described
Euclid
from a centre, at a distance from that centre.
Euclid never mentions level, does he, Bab?
No.
There you go.
I was just saying he might have hidden it in there as an Easter egg for you. Just change circle to level whenever you want. I mean, it'll work brilliant.
Just the fact that you said a 2-mile airstrip that is completely level is curved. And
so can you derive? Did they leave?
Oh no!
I was gonna ask. I was just getting ready to ask. Can you derive pi from level? Oh,
damn!
He left. Yeah, I knew that would be too much. Yeah,
it was going. So that was good.
A level curved runway, huh, Brenda? Yeah.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.